Hey everyone, welcome to this video. And in this video, I'm actually going to be solving Codeforces around 856 Div-2. And we'll be doing problem A, B, and C. I tried D. The contest is still going on, by the way. I tried D, and I know how it is going to be solved, but it takes a lot of maths, and I don't really know that much in CP. So I'm not trying anymore. So I'll be doing problem A, B, and C. And let's start with problem A. A, B, and C, all three problems were pretty easy actually. If you are an expert level coder on Codeforces, you should have been able to do A, B, and C. Okay, A and B are pretty easy. C is also very easy. Alright, so let's start with the very first problem. A, prefix and suffix array. Marcos loves strings a lot, so he has a favorite string S consisting of lowercase English letters. For this string, he wrote down all the non-empty prefixes and suffixes except for S on a piece of paper in an arbitrary order. So basically, he had a string S and he wrote down all the prefixes and suffixes. As we know, a prefix is nothing but the entire string except we have removed some characters from the end, and a suffix is nothing but the entire string except you have removed some characters from the starting. Okay, so we have taken all the prefixes and the suffixes except the entire string, okay, on a piece of paper in an arbitrary order. All right, so you see all these strings and wonder if Marco's favorite string is a palindrome or not. A palindrome is nothing but which can be read in the same way from the forward to backward and backward to forward. Okay, so we need to decide if the initial string that Marcos had, if that was a palindrome or not. So let's see. If you All right, so let's take the very first input. If you see, so if you look at this, n is actually what? 4. If n is 4, how many strings will we get? We have said that we'll get 2n minus 2 strings. How? One prefix, two prefix, third prefix. We cannot take the entire string, so we are not taking that. Okay. Then similarly, if you look at suffixes, we'll have one suffix, two suffix, and three suffix. So three prefixes and three suffixes in total. Okay. That means 2n minus 2 strings. N minus 1 suffixes, n minus 1 prefixes, total 2n minus 2. Okay, I hope this is clear. Alright, so although this was not required. Okay, so in total we are getting 2n minus 2 strings. Okay, we need to figure out what if the initial string was a palindrome or not. If you see, the strings here are these, and the complete string was ABCD, which was not a palindrome. Let's look at the next case. For this one, the entire string was IOI, which is a palindrome. Okay, we know how to check a palindrome. All we have to see is figure out the entire string. But is there some way we can actually skip that part? If you see, if you actually look at this part, okay, you will see that we had one prefix of length n minus 1 and one suffix of length n minus 1. And this prefix and this suffix actually had almost all the characters of S. Okay, so if this was your entire string, okay, you had a prefix, okay, and you had a suffix. Okay, let's say the string was A, B, C. Okay, blue is not visible. Is green? Yeah, green is visible. Okay, A, B, C, B, A. Let's say this was the string. So the prefix with n minus 1 length would be A, B. Let me take black only. The prefix with n minus 1 length will be A, B, C, B. And suffix with n minus 1 length will be B, C, B, and A. If you actually reverse this, this becomes ABCB, which is nothing but the prefix only. So all we have to do is look for strings with length n minus 1. One of them will be a prefix and the other will be a suffix. Just reverse any one of these and check if they are same. If they are same, that means it is a palindrome. That's it. That's all you have to do. Okay. Okay. The question is pretty easy. Let me just show you the code as well. All right. So this is the code. Okay. And as you can see, all I'm actually doing is, okay. Yeah, all I'm actually doing is I've taken all these strings. Okay, I'm checking if any string's length is n minus 1, then I push it into my can vector, and then I know I'll have two strings in this can vector. Okay, one will be prefix, one will be suffix. Now I have to reverse the suffix. That's all. Okay, so all I have to do is take the second character, the second string, reverse it, and then see if both of them are same. If both of them are same, then the answer is yes, else the answer is no. That's it. All right, so I'm pretty sure everybody was able to do this problem. Okay, so let's jump on to problem B, which is not dividing. Okay, so the question says that you're given an array A of n positive integers a1 till an. In one operation, you can choose any number of array and add 1 to it. Okay, make at most 2n operations so that the array satisfies the following property: ai plus 1 is not divisible by ai for each I till n minus 1. Okay, so basically what the question is saying is, okay, so you have an array with a1 till an. Okay, that is what's given. Just a second, I think there's some lag between my video and the screen. Yeah, there is some lag. Okay, just give me 1 second. Oops. Okay, I shouldn't have done this right now, but anyways, just give me 1 second. Okay, all right. So now I think there won't be any lag. Okay, yeah. Okay, so we're given the entire array a1 till an. Okay, and now what we have to do is we have to make sure that ai is not divisible by ai plus 1 is not divisible by ai. Okay, for every I. Okay, and the operation that we can do is we can actually add one value to any character, like to any index. Okay, and we can do this at most 2n times. Okay, we don't need to minimize the number of operations. All we have to do is return the array, okay, in which ai plus 1 is not divisible by ai. Okay, so let's take the very first input. Okay, so this is the very first input, which is 2, 4, 3 and 6. Okay, now what we actually need to do is, if you see, 4 is divisible by 2. Okay, so let's say we increase one. So we made 2, 5. Then we have 3 and 6. 3 is not divisible by 5. Okay, but 6 was divisible by 3. So let's make it 7. Okay, and if you see this, in this, no ai plus 1 is actually divisible by ai. Now, how do we actually do this? Okay, let's see. So let's suppose that some ai plus 1, okay, when divided by ai gives a remainder of 0. That means ai plus 1 is divisible by ai. Now, if that is the case, what if we add 1 to a of I plus 1? If we actually add 1 to ai plus 1, we are sure that it won't be divisible by ai anymore unless and until ai is not equals to 1. So there are two things. First, we need to ensure that ai is never equal to 1. Because if it is equal to 1, no matter any value we add to ai plus 1, it will always be divisible by ai. So we need to make sure that every element is greater than 1. Okay, except the last element, because ai can be every element from first till second last element. Okay, for last element, we don't really need to do that. That can be 1 also, because that is not dividing anything. Okay. So from 1 till n minus 1th index, we need to ensure that every element is greater than 1. That is the first thing. Next thing that we have to do is just see if ai plus 1 when divided by ai gives something that is not 0. If it is 0, then just add 1 to ai plus 1. That's it. Now, why this works is because let's say we had some array. Okay, let's say we had some array. Let's say of 5 elements. Now, the first thing that I said was we need to add plus 1 to every element. Okay, if they are equal to 1. Okay, let's assume like everything was 1 only. So how many times we will actually have to add 1? We'll have to add 1 4 times, which is nothing but n minus 1 times actually. Now if you see, first element is fine. We don't really need to do anything. Maybe next element is divisible by the previous one. So we will add plus 1. Similarly, let's say again the case comes that the next element was divisible by the previous one. Again plus 1. In such a way, we'll have to do maximum n minus 1 operations. So in total, we'll actually do 2n minus 2 operations only. And that is how this works. Okay, so let's take the very first case only that we actually did. Let's take something else. Let's take second case. Okay, so we had 1, 2 and 3. Let me rub this. Okay, let's take this only. Let's say, so we had 1, 2 and 3. We had 1, 2 and 3. The first thing was always take if any element from the first one till the second last one is not equal to 1. Okay, since this is equal to 1, we need to add 1 to it. So the array becomes 2, 2 and 3. Now check if ai plus 1 is divisible by ai or not. Okay, as you can see, this is divisible by this 2. So we need to have plus 1 here also. So this becomes 2, 3, 3. Again, if you see, this 3 is divisible by this 3. So again a plus 1. So we have 2, 3 and 4. So in total, we actually did 3 operations. Okay, 1 operation, 2 operation and third operation. Okay, and we are able to get an array in which ai plus 1 is not divisible by ai for all indexes. Okay, and that is pretty much the answer also. We can have multiple answers. Okay, this is one such answer. That is all we have to do. Let me show you the code as well. Again, pretty easy question. Uh, as you can see in the code as well. Okay, as you can see in the code as well, first I'm just scanning the entire array. Okay, then I'm just checking for the first element if it is equals to 1. If it is equals to 1, then I just increment it. Then for all the subsequent values, what I'm actually doing is, if the value is equals to 1 and I is less than n minus 1. So basically, if it is any element except the last element, increment it, because we cannot have it equal to 1. If it is equal to 1, it will divide every number. Okay, then the next thing that we have to do is check if this number is divisible by the previous number. If that is the case, increment my current number. We have done both the conditions. Now just print the entire array. That's it. All right, so I hope this is also clear to everyone, and we can move forward to problem C. All right, so problem C is scoring subsequences, and as we can see, 10 minutes are left, but still like 3335 submissions are here, so like it's also an easy problem only. All right, so let me just explain what we have to do. The score of a sequence S1 till SD is defined as S1 times S2 times so on till SD divided by 10 d factorial, where d factorial is 1, 2, 3 till d. In particular, the score of an empty sequence is 1. Okay, so basically, if we have a sequence, let's say ABC, okay, its score will be given as A into B into C divided by the length of the sequence, which is 3. So 3 factorial, which is 6, ABC by 3. That is actually going to be the score. Now what they're saying is, for a sequence, let M be the maximum score among all its subsequences. So if we had the sequence A, B and C, we need to consider every subsequence, which is A, B, C, AC. Okay, these are all the subsequences. Now what we have to do is find the score of every subsequence. Whichever subsequence has the maximum score, okay, that is going to be the length of that subsequence is going to be the cost. Okay, I'll explain this again. So basically, what they're trying to say is, oh, let me just take a, okay. So what they're trying to say is, let's say we had A, B, C, D. Okay. One subsequence is A, one subsequence is B, one subsequence is C, one is, let's have ABC only. Okay. One is AB, one is BC, one is AD. Okay. And one is the entire subsequence, which is ABC. We need to find score of this one, this one, this one, this one, this one, this one, and this one. Whichever subsequence has the highest score, the length of that subsequence is actually going to be the cost. For example, let's say BC had the maximum cost. Let's say just BC had the maximum score, then 2 is going to be the cost. Okay, so what do we have to do? You're given a non-increasing sequence. Okay, the sequence is non-increasing means it is increasing. Okay, not strictly increasing, it is increasing. So we can have 1, 2, 2, 3 in such a way. Okay, of integers of length n. In other words, the condition this. Okay, a sequence x is a subsequence of sequence y if x can be obtained from y by deleting several elements. Okay, cool. So let's take the very first input and try to see like what they're actually trying to say. Let's say, so we have three elements, 1, 2 and 3. Okay, okay, I missed something actually in the equation. Uh, yeah, I missed this one. For okay, in other words, the condition this for each k, find the cost of sequence. Okay, so we need to find the cost of sequence for each k. So basically, if the entire array is this 1, 2, and 3, okay, first we need to consider only one, then we need to consider 1 and 2, then we need to consider 1, 2, and 3. Okay, so first let's look at one only. Since there is only one element, the score is going to be 1 only, because the only value that we have divided by the length of the sequence, that is 1. Okay, the score is going to be 1, and since the length of this is 1 only, answer is 1. As you can see, answer is 1. Okay, let's look at 1 and 2. If we have 1 and 2, one sequences just take 1, one sequences just take 2, and one subsequences 1 and 2 both. Score of this is actually going to be 1. Score of this is going to be 2. Okay, because the value upon the length, which is 1. Score of this is going to be 2 into 1 by 2 factorial, which is nothing but 1. Since score of this is maximum, length is 1. So the cost is going to be 1. Similarly, let's look at this one, 1, 2, and 3. Okay, let's look at 1, 2, 3. Now, if you look at 1, 2, 3, what are all the possible cases? Some cases are the above ones only. These cases will remain. The remaining cases are either take only 3, either take 1, 3, either take 2, 3, or take the entire sequence, which is 1, 2, and 3. For this 3, the answer is going to be 3. Okay, 1 and 3, the answer is going to be 3 by 2. For 2 and 3, the answer is going to be 6 by 2, because 3 into 2, which is 6, and then 2 factorial, which is the length, that actually gives you 3. And 1, 2, and 3 will actually give me 3 times 2, 6 by 3 factorial, which is 1. As you can see, 3 is maximum. 3 is here also and here also. Since this 3 came from a length of 2, answer is going to be 2. We have to maximize the length as well. Okay, so the answer is 1, 2, and 3. And as you can see, answer is 1, 2, and 3. Now, how do we really do this? Let me go back to my board. Okay, so let's say we had an array, we had some values. Okay, and we are given this is an increasing sequence, non-decreasing actually, non-decreasing. Okay, which is nothing but increasing. Okay, all right, so which means we have some value x. Here we might have x plus 3, here we might have x plus 5, here we might have x plus 10, and here we might have x plus 15. The values are going to be increasing or same. Maybe if this was 5, this was also x plus 5. Okay, that is allowed, but it cannot decrease. Okay, because of this, we know that for any given array, okay, let's say this is the array. Okay, and let's say we were trying to find for this part. Okay, the answer is going to be in this direction only. That will either take only this element, or we might take both these elements, or we might take all the 3 elements. It will never be that we just have to take this element, because the values were increasing. So it is better to take the last element instead of the second last element, because the last element might have a greater value. Okay, so this part is clear, that the answer will always start from the end. Okay, now let's say this was the sequence. Okay, and we are done till this index, and the answer, okay, let's write a1, a2, a3, a4, a5. Okay, we are done till, let's say, a4. If we are done till a4, that means the score of a1, a2, a3, and a4, let's say, came out to be a3 into a4 upon 2 factorial. Let's say this was the answer. How do we find the answer for a5? We know that the answer will start from a5, that is for sure. A5 will be present in the answer. Now we need to check if a4, a3, a2, a1 might be present or not. Okay, now since the answer came from these two elements, okay, if you see, if we take these two elements, a4 and a5, okay, if you take a4 and a5, this will be divided by 2 factorial. This value will always be greater than the previous value. The reason is, so the length of this was, let's say, x. What I'm actually trying to say is that if the length of the previous answer was x, you need to take the same x values except the first value. Remove a3, take a5, because we know that a5 is actually greater than a3. Since a5 is greater than a3, this value will be greater than this one. Now check if a3 can be a part also. After doing this, just check if a3, a4, a5 by 3 factorial is greater than this one or not. If this is true, then take this, otherwise this will be the answer. Now, if you see the constraints, we cannot really find the value of this because this value might become very large. To do that, what we have to do is, okay, so just a refresher. If we had some number of elements, let's say, okay, let's say we were done till this index, okay, and the answer for this came from these values. Okay, so let's say we took some x values. Okay, we started with what? A1, A2, so on till AX. Okay, we had some more values. This is like A0 and something else. Okay, the answer came from all these values. Okay, so this is AX. Okay, the answer was A1, A2, A3, so on till AX divided by x factorial. Now what I'm saying is my new answer for the entire array is actually going to be A2, A3, so on till A of x plus 1 by x factorial. All I've done is removed A1 with A of x plus 1. Now I need to see if I should add A1 or not. Now, if I add A1, what am I actually doing? I'm multiplying the numerator by A1, and in the denominator, it should be x plus 1 factorial because earlier length was x. Now I'm adding one more value, so x plus 1 factorial, which actually means I'm multiplying the denominator by x plus 1, which actually tells me if my A1 is greater than equal to x plus 1, then only it makes sense for me to multiply by A1. If it is lesser than x plus 1, then I know my answer will actually decrease. So all I have to do is just check if this element is greater than x plus 1. If it is greater than equal to x plus 1, why greater than equal to? Because we are actually maximizing the length as well. That is why we also need to take the cases in which it is equal to. Okay, so if it is greater than equal to, then take the first value as well. Otherwise, don't take the first value. And that is all we have to do. So all we had to do was, let's say we had some values. For the very first case, the answer would have been 1 only. That take the very first value, which is A1. Okay, and that's the answer. When you have two values, now check. Now you know answer will be A2. That is for sure. But it might be that A1 might also be included in A2. So all you have to do is check the length, which becomes 2 if A1 is greater than 2, greater than equal to. If it is greater than equal to 2, then the answer is going to be like both A1 and A2. Otherwise, the answer was just A2, and so on. Keep the method going and the answer will come for every case. All right, so that's pretty much it for this question as well. Let me show you the logic. Okay, the contest is also over. Okay, anyways, let me show you the code as well. This is the entire code. So what are we actually doing in this one? First I just scanned the entire array. Then for the very first value, I just said that my answer is 1. I printed out 1, and my count of the answer array, all the elements which I'm actually taking in the answer, is 1. Then for all the remaining values, I'm actually starting for the next index, which is I equals to 1. I just take, let's say I'm actually done till this index, and in count I'm storing all the values that I've taken for the answer. Let's say my count was 2. This is 0, 1, 2, 3, and 4. When I have to consider for the last value, okay, my answer was coming from these two values. Now I know I have to take these two values for sure. So the very first thing, okay, these two values I have to take. I also need to check if I should take this one value. So what is this? My I is at 4. 4 minus 2 is actually this index. So I just have to check if array of I minus count is greater than equal to count plus 1, because if I include this one, my total count will be count plus 1. So I have to multiply the denominator by count plus 1. If that is greater than equal to count plus 1, then count plus plus, that I am now increasing the length of my answer. So count plus plus, else everything remains the same, and for every case I'm just printing out the count. That's it. That's all you have to do for this problem. Okay, so it's more like an intuitive problem, not much to implement in this one. All you have to do was just think a little bit about like how the constraints are given and everything, and that's all you have to do. All right, so that's it for this contest. I hope you like the stream. If you did, do like the stream as well, and also share with your friends as well, because I actually like get many messages that these streams are helping a lot to many people. So yeah, do share this stream, and that's it. I'll see you in the next one.